So, in the last lectures, uh, we just understand the determination of crystal structure or the lattice structure of NaCl. Okay, so this determination of crystal structure or the lattice structure of these any crystals with the help of Bragg's equations. Okay, so that Bragg's equations, because we know that the from the X-ray diffraction methods, that is the rotating crystals methods and the Cherer methods, Hebbe-Cherer methods or the powder methods, that give the informations about the angle theta and their reflections. Once we measure this with the help of this monochromatic X-rays, right? And on the basis of that we can in a crystals there is a set of lattice planes and interplanar distance there, and on the basis of that the intensity of the reflected beams we can measure uh, with the help of these two methods. But the most probably we are using to determinations of this angle and the reflections of these crystals, it is only been only on the basis of this rotating crystals methods. It is very famous methods, and that will be the always used probably in the determinations of this X-ray diffraction. Okay, so on the basis of that, these crystals having the planes like 100, 110, and 111. So these crystals having these planes 100, this is one plane, second is the 110, and third one is the 111. So these are the interplanar distance, or it is the planes which is present in a crystals of such NaCl crystals, right? So, and the basis of this, we can find out their angles, the closing angles or that's reflected angles for which made with the help of this reflected beam and the incident beam. So that maximum reflections for the first order are observed at the angles for this one. Theta is equals to theta here for this 100 plane, that is the 509, and here degree. Here is the this 8.4 degree, and here is the 5.2 degree. So once we get this angle on that method of the rotating methods, then from the Bragg's equations, and we know that the Bragg equation is n lambda is equals to 2d sine theta. So this is your the Bragg's equation. Okay. From these Bragg's equations, we can find out the crystal structure of this NaCl. So here n is the order of reflections, and lambda is the wavelength of X-ray monochromatic light, which is the incident on this your sample. Both the factors are constant. So n and lambda is constant. Constant means here is the some values and which is not change. And here the reflections of order it is just like 1 2 3 like this. But the for one it is it not change for the one place, and the second order is not changed. So it is constant values. So if it is constant, then these equations we can write here the d, the interplanar distance. D is the interplanar distance is proportional to 1 upon sine theta, right? So we know that once we get the values of the theta, then put this value into these equations, and the interplanar distance for this HKL or this planes we can write the D100. Their ratio is D110 is to D111. So this is the interplanar distance, and we know the angle of reflections for this each planes. So that is the 1 upon sine, that is theta means here the 5.9, right, is to 1 upon sine, the angle is 8.4, and this the is to 1 upon this theta, that is 5.2. sine 5.2. So this is the angle degree. So the sine 5.9 is 0.1028. Sine 8.4 degrees 0.146, and sine 5.2 is 0.0906. So this is the sine theta for this angle 5.9 and 8.4 and 5.2 respectively. It will comes these values 0.1028 is to 1 upon 0.1460 is to 1 upon this 0.0906, right? So this is the ratio, and it comes the value, right? 1 upon 1 is to this 0.704 is to 1 upon is to 1.135. So this is the values. It is just like similar to the values of the standard values of the FCC. FCCच्या standard values सोबत हे match होते, and so this is the values. It comes from this 1 is to root 1 upon root 2 is to 2 upon root 3. So this is the values, standard values. This is the standard values which is comes from this, right? So this standard values for FCC, and therefore the NaCl crystal is the FCC crystals. Okay, so this the face centered cubic lattice of your it's because it is a similar value, or this is the ratio of these FCC crystals or the FCC lattice of a NaCl belongs to the FCC crystals. So in a NaCl crystals, there may sodium and the chloride ions. It may ions, or it may atoms, or it may molecules. So this NaCl crystals, when we observe the first order, second order, third order reflections, that is from the 100, 110, and 11 plane. So 100 and 110 planes, it's our decreasing order. So that is the decreasing order of their intensity of reflections of this order 1, 2, 3 like this. But if you observe from the 1 planes, so that is the first order reflection, it is weaker. Second order reflection, it is stronger. Third order reflection, again it is weaker, and fourth order reflection again is stronger. So it means that only 1 plane, there is a odd order reflections, that is 1, 3, and 5 like this. It is the weaker reflections, but the even order like 2, 4, 6 like this, so that is the stronger reflections. So on that basis we can say that the Braggs has suggested Na and chloride atoms, sodium and chloride ions are the structural units or of centers of these reflections. And there is not it is molecules. हे molecules नाही तर एक तर तो atoms असणार आहे किंवा ions असणार आहे. So this is always, it is present in an ionic form. So as Na and the Cl ions are held firmly by the electrostatic force of attraction, due to this it is present in ions. So in a NaCl crystals, your sodium and the chloride, it is present in an ionic form, and therefore it is having the electrostatic force of attractions between them. So this is the form of these ions, Na plus and the Cl minus ions. So these planes 100 and 110 planes contains equal number of both sodium and chloride ions. But when in the reflection of 111 planes, that Na plus planes, or this Na plus ions, it's exactly in the phase of this reflections of the intermediates, that is the chloride ions, right? So this is lying the halfway between these Na plus ions, and therefore it causes the interference. हे याच्यामध्ये येते आणि त्याच्या हाफवे असतोय, आणि त्याच्यामुळे या दोघांमध्ये जे काही रिफ्लेक्शन्स होते त्यामध्ये इंटरफेरन्स तयार होतो. आणि ह्या इंटरफेरन्स मध्ये ही जी इंटेन्सिटी असेल याची, सो दॅट विल बी द वीकर्स. ती जी इंटेन्सिटी असेल की 1 1 1 प्लेन मध्ये ती काय होते, विकर होते. ओनली दोज रिफ्लेक्शन्स विच इज दी first, third, or this odd reflections. So this is the only reason why this is weaker. Okay, and why not it is follow the order of decreasing or increasing intensity of the order of reflections. So on the basis of this causing the interference that because of the path difference, आता हे जे कशामुळे होते तर path difference जो असेल, so that path difference it is fractional multiples to the wavelength of the monochromatic light or a monochromatic or the X-rays beam. Hence, the first order reflection is weak. But the second order reflection, the path difference becomes in a single multiples wavelength. म्हणजे जेव्हा पाथ डिफरन्स हा तुमचा फर्स्ट ऑर्डर मध्ये असेल त्यावेळेस याच्या इंटरफेरन्स होते आणि त्याच्यामुळे जो पाथ डिफरन्स असतोय हा फ्रॅक्शनल मल्टिपल असतो, लाईक दिस वन और दिस पॉइंट 5 like this into lambda. But the second order, it is not it is a whole number like your 2 or something like this into lambda. So therefore it is a stronger one and this is the weaker one, right? So in this way, this is the only because of the path difference, and this path difference it is changes because of this number will be fractional or the whole number. It will be depends on the interference which is causing between this Na plus and Cl minus half. This your Cl minus ions comes into the halfway between this Na plus ions and their phase, right? So this NaCl crystals, which is Na plus ions, is surrounded by the all 6 chloride ions, and the all chloride ions having this surrounded by the 6 Na plus ions. So in this way, this NaCl crystal is interlocking to with each other between this two units of the Na plus and unit cells of the Na positive and the unit cell of the Cl minus ions. त्या दोन युनिट सेल्सचे इंटरलॉकिंग करतात आणि त्यामुळे हा जो NaCl क्रिस्टल्स असतो इट्स हाफ वे इंटरलॉकिंग ऑफ युनिट सेल ऑफ Na positive and the unit cell of the Cl minus ions. Okay, this is all about the crystal structure of NaCl. हे सगळं NaCl चं क्रिस्टल स्ट्रक्चर आपण अशा पद्धतीने डिफाइन करू शकतो किंवा we can determine the NaCl crystals with help of this, right? And now we are going to discuss the second crystals, that is the KCl. KCl also it is just similar to the NaCl crystals. NaCl crystal सारखंच याचं क्रिस्टल स्ट्रक्चर असतंय, but it is slight difference between the KCl and NaCl. But both the structure it is FCC. Both the structure is FCC. But on the determinations values, this KCl it is a simple cubic structure. It is simple cubic structure. Don't confuse, okay? Simple cubic structures or the simple cubic or it is called as the simple primitive structures. हा सिंपल क्युबिक स्ट्रक्चर आहे. हे कशावरून? फॉर द कॅल्क्युलेशन, द कॅल्क्युलेशन व्हॅल्यूज ज्या आहेत ज्या आपण ब्रॅग्स इक्वेशन वरून काढतोय, ऑन दॅट बेसिस वी कॅन से दॅट इट इज अ सिंपल क्युबिक स्ट्रक्चर. but it is the just see this structure, it is just like FCC. आता ते कसं असते आपण ते बघूया. First, we can find out the values, standard values, okay, on the basis of Bragg's equations, on the basis of the from Bragg's equations, from Bragg's equations. आता ब्रॅग्स इक्वेशन्स वरून याच्या व्हॅल्यूज कशा काढायच्या ते आपण बघितलंय की first of all you determine the X-ray from the X-ray diffractions method, that is the rotating methods, crystals methods. We can find out the angle theta. आपल्याला थीटा काढायचा आहे. अँगल, ग्लेझिंग अँगल्स, हा ग्लेझिंग अँगल्स कशाचा असतोय? द इन्सिडेंट लाईट अँड द रिफ्लेक्टेड लाईट इट्स मेक अ अँगल. सो दिस अँगल्स अँड दिस इज अ वन प्लेन, राईट? सेकंड प्लेन, थर्ड प्लेन. सो दिस इज द planes which is present in your crystals, and on that basis we can find out their angles. त्याचे angles आपण काय करतोय? फाइंड. हे जे angles तयार होतील ते angles आपण फाइंड आउट करतोय. That is called as the theta. So this theta, once we know the theta, then and the reflection intensity or the reflection first order, second order, third order, then the job is very easy to find out the standard values for the FCC simple cubic and the BCC, right? So on the basis of this first order reflection maxima for the this plane 1 0 0, then 1 1 0 and 1 1 1 plane. So this is the planes, and we can find out the interplanar distance between in the these planes. So of KCL planes is first order maxima, and the angles observed for these planes, that is angle theta 1, that is it is 5.3 degree, theta 2 for the planes of this 1 1 0 it is 7.3 degree, and theta 3 it will be this 9.05 degree respective. Okay, then the ratio of this one, आता आपल्याला इक्वेशन आहे, ब्रॅग्स इक्वेशन आहे, एम लॅम्बडा इज इक्वल्स टू 2d sin थीटा, हे कॉन्स्टंट असल्यामुळे आपण याला d proportional to 1 upon sin theta असं लिहितोय, राईट? So then the ratio of interplanar distance is given as, then ratio of interplanar distance is given as distance is interplanar distance means d. So d for 1 1 0 plane is to d for 1 1 0 d for 1 0 0 plane is to d for 1 1 0 plane and d for 1 1 1 plane. So this is the value of HKL. यालाच आपण जनरली कसं लिहितोय, DHKL. So HKL म्हणजेच this values 1 0 0 1 1 0 and 1 1 1. Okay, so this is the distance, and it will from these equations, या equations वरून आपल्याला कसं लिहिता येईल. So d is equals to or d proportional to 1 upon sin theta. आता sin theta याचा sin theta काय असणार आहे, तर for this one, this 5.3 degree is to 1 upon sin theta 2, that is the 7.3 degree, and 1 upon sin theta 3, that is the sin 9.05 degree. When you find out the sin 5.3 degree, sin 7.3 degree, and sin 9.05 degree, so we'll get the answer for this one, that is 0. Sin 5.3 it is 0.0924. हे कुठून येतंय, तर जस्ट वी सी एकच आपण बघूया. सो वी कॅन कॅल्क्युलेट दिस साइन, किती आहे साइन 5.3. सो 5.3, this is a scientific calculator, trigonometry and sine. So here we see this values is 0.0923. Okay, so आता पुढच्या व्हॅल्यूज आपल्याला हे करायचे आहे, मग मी होल नंबर करतो, दॅट इज 0.0924, right? So this is the values of your sine 5.3. In this way, similarly, when you calculate the sine 7.3 degree, that is the 0.1271 is to 1 upon sine 9.05, it is 0.157. So once we get these values, we can easily calculate this one, and it will comes, this is the is to 1. Actually हे जर केलं तर तुम्हाला 10 point something येते. So one digit is comes, that is 1.0 something. So it is 1 is to 0.7269 is to, this is the calculations of this one, and 0.5874. हे अशा पद्धतीने येते 5 point something 7 point something. So it will comes one digit here, so that is 0.7 and 0.58 something, right? So this is the values, this is the standard values. It is just similar to simple cubic structure. त्या कशाच्या व्हॅल्यूज आहेत, तर सिंपल क्यूबिक स्ट्रक्चरच्या स्टँडर्ड व्हॅल्यूज. सो जस्ट सिमिलर विथ द सिंपल क्यूबिक स्ट्रक्चर्स ऑफ दिस your KCLs shows the similar values लाईक युअर सिम्पल क्युबिक स्ट्रक्चर सारख्या तो सिमिलर व्हॅल्यूज तुम्हाला दाखवते. आणि म्हणून दिस व्हॅल्यूज वी कॅन राईट दी D100 is to D110 is to D111 is 1 is to 1 upon root 2 is to 1 upon root 3. So this is the standard values of simple cubic structure. This is the standard values of simple cubic structures. ह्या simple cubic structureच्या standard values आहेत त्या की आपण बघितले, right? So these standard values of simple cubic structures जे आपण आधी बघितलेले आहे की जेव्हा आपण सिंपल क्युबिक स्ट्रक्चर्स किंवा एफसीसी किंवा बीसीसी बघितले त्यावेळेस आपण त्या व्हॅल्यूज बघितल्या की दिस इज द व्हॅल्यूज विच विल फॉर दी स्टँडर्ड व्हॅल्यूज फॉर दी simple cubic structure or FCC or BCC. Now, so this is the ratio of simple cubic lattice, and it can be said that the KCl it is a simple cubic structure. So KCl is simple cubic structure. Simple cubic structure. It is simple cubic structure, right? Simple cubic structure, right? But the matter of this fact that is KCl belongs to the FCC cubic lattice. पण ऍक्च्युली जरी ह्या व्हॅल्यूज तुम्हाला सिंपल क्युबिक स्ट्रक्चर असेल तर याचा फॅक्ट काय आहे किंवा इट इज ट्रूली वी कॅन से दॅट द फॅक्ट ऑफ दिस वन इट इज एफसीसी. इट इज एफसीसी. तर ते कसं? So the structure of similarly NaCl. So this NaCl shows the similar structure with the your NaCl. KCl shows the similar structure of your NaCl. NaCl सारखा तो structure दाखवतो. For example, this one. This is the cubic structure of your the NaCl and your KCl shows in this way. अशा पद्धतीचंच तुम्हाला स्ट्रक्चर दिसतंय तुम्हाला याचं सुद्धा. मी अशा पद्धतीने जर काढलं तर इट इज शोज द सिमिलर स्ट्रक्चर्स लाईक दिस in this way, right? So this is the similar structure shows the this one, right? So this is the four cubes 1 2 3 4 असं जे सेम स्ट्रक्चर आहे हे तुमचं NaCl चं स्ट्रक्चर आहे. युअर KCl ऑल्सो शोज देअर स्ट्रक्चर इन दिस वे. या पद्धतीचंच ते स्ट्रक्चर दिसतंय. ही फॅक्ट आहे. बट हा एफसीसी आहे आणि तुमचा स्टँडर्ड व्हॅल्यू जे सिंपल क्युबिक स्ट्रक्चरच्या केसीएलच्या. पण तो दिसतोय कशासारखा? एफसीसी सारखा. तो का तसा दिसतोय? तर त्याचं कारण असं आहे की जर तुम्ही आता फॉर एक्झाम्पल if you take and the ratio of the values of this NaCl and KCl, NaCl KCl च्या जर तुम्ही एक्झॅक्टली व्हॅल्यूज घेतल्या आणि त्याचा रेशिओ जर घेतला तर वी कॅन इझिली फाइंड आउट दिस. ते इझिली फाइंड आउट करू शकतो. Just wait, okay? We can find out it, right? See, if you take an this one plane that is a 100, हा एकच प्लेन घेतलाय. हा घेतलाय आपण ऑफ KCl चा आणि त्याला डिवाइडेड केलंय सेम प्लेन 100 फॉर NaCl ऑफ NaCl प्लेन. हे किती आहे तर साइन 5.9 डिग्री आहे. ओके, हे आपल्याला माहिती. सॉरी, this is your NaCl, okay? This is your KCl. आणि हा किती आहे तर साइन 5.3. ओके, या दोघांचा रेशो काढला तर हा किती येतोय? हा येतोय 1.113. So this is the ratio of your one plane of both the values. या दोन्ही KCl ची ही NaCl ची व्हॅल्यूज आहे फर्स्ट फॉर दिस प्लेन. This is the value for KCl for this plane. And if you take an ratio of these values of this plane, same plane of this NaCl and KCl, so it will comes the 1.113. आता ही व्हॅल्यूज एक्झॅक्टली काय आहे? So this is the values. It is the volume of unit cell. This is the values. It is the volume of unit cell. Unit cell. युनिट सेलची जी व्हॅल्यूज आहे ती व्हॅल्यूज म्हणजे ही आहे आणि ती किती आहे तर D 100 raised to power 3. सो दिस इज द युनिट सेल व्हॉल्यूम आणि ही जी व्हॅल्यू आहे D100 रेस टू पॉवर 3 ही जो व्हॉल्यूम आहे युनिट सेलचा ही आहे 1.1 सॉरी इट इज 1.39 ही एक्झॅक्टली ती आहे राईट. आता द रेशिओ ऑफ दिस मॉलिक्युलर व्हॉल्यूम ऑफ KCl और NaCl इज आता याचा जर रेशिओ घेतला तुम्ही आणि याचा जर हे केलाय तर तो किती येतोय तर तो एक्झॅक्टली 1.113 रेस टू पॉवर 3. सो आता हा जर तुम्ही कॅल्क्युलेट केलंय रेस टू पॉवर 3 तर इट विल कम्स 1.379. It will comes 1.379. So this is the volume of your unit cell. It is similarly the standard volume of this unit cell, that is 1.39. ही similarities तुमच्या या स्ट्रक्चर मध्ये दिसते when you taking the ratio of this plane of a NaCl and KCl. So it comes the ratio, it is 1.113, and if it is taking the this volume of unit cell, that will be the 1.379, and it is the value, it is similar to the standard volume of the unit cell, that is 1.39. So this is the molecular volume of NaCl or KCl ratio. त्याचा जो रेशो आहे molecular volume चा तो 1.379 आहे. So this is the good agreement of this ratio with the experimental values of this volume of unit cell. So HRC तो good agreement करतो किंवा एकदम similar आहे. So these two values, it will be suggested that the NaCl and KCl and KCl have the FCC structure, have the FCC structure. त्या दोघांमध्ये काय आहे FCC स्ट्रक्चर आहे ते कशावरून आपण सिद्ध करतोय इव्हन तो the standard values says that the NaCl is the FCC and KCl is the simple cubic, but when you taking the any plane of this NaCl or KCl and their ratios, then the molecular volumes values it is comes the 1.37 and the standard experimental values which is calculated 1.37. It is a good agreement with each other, and thus on the basis of these two values we can say that NaCl and KCl having the FCC crystals, आणि म्हणून FCC crystal structure तुमचं KCl आहे. So for this reason, this KCl showing the scattering pattern as like your simple cubic. So KCl is both K plus and the Cl minus ions. आता जसं स्कॅटरिंग पॅटर्न तो दाखवतोय सिंपल क्युबिक मधल्या सारखा, त्यामध्ये के प्लस आणि Cl मायनस आयन्स आहे, जे की आपण असं म्हणतोय की ज्यामध्ये किती आहे तर याच्यामध्ये सुद्धा 18 इलेक्ट्रॉन्स आहे आणि याच्यामध्ये सुद्धा 18 इलेक्ट्रॉन्स आहे. हे दुसरं रिझन की पोटॅशियम मध्ये सुद्धा आउटर मोस्ट सेल मध्ये 18 इलेक्ट्रॉन आहे आणि क्लोराइड मध्ये 18 इलेक्ट्रॉन्स सिस्टीम आहे. So this is the reason. Hence both the ions scatter to the same extent. म्हणजे हा आणि हा दोन्ही scattered होत असतात आणि same extent ने तो scattered होईल. It will be scattered in the same extent. But this is not happen in the case of the NaCl. NaCl मध्ये असं होत नाही. असं का होत नाही NaCl मध्ये? Because so that आता हे जर सेम पॅटर्न जर स्कॅटर्ड होत असेल तर याला आपण डिस्टिंग्विश करू शकत नाही. सो बोथ द आयन्स इट इज indistinguishable, right? Both the ions it is indistinguishable. So if it is indistinguishable, but this is not the case in case of this NaCl. NaCl मध्ये असं नाही. NaCl मध्ये असं का नाहीये तर the scattering patterns behaves if made up of simple cubes. आता हा काय करतोय याला सिंपल क्यूब आपल्याला दाखवतोय, but the in a NaCl crystals there is the Na positive ions and Cl minus ions. So the Na positive ions, it has the 10 electron system and Cl minus having the 18 electron system. So the scattering pattern of this and casting pattern of this, it is different. या दोघांचे scattering patterns काय आहे different आहे. So if the scattering pattern of this one and this one is different, both the ions, so scattering pattern of these two ions it is different and it can be distinguished. So this is the reasons also to this it shows the FCC pattern. हा FCC pattern दाखवतो, हा simple cubic pattern दाखवतो. So this is the again the simple reason why this KCl shows the FCC pattern. So is this is the distinguished points and this shows the scattering patterns also. आता अशा पद्धतीने आपल्याला काय करता येते, केसीएल हा क्रिस्टल स्ट्रक्चर डिफाइन करता येते किंवा डिटर्मिनेशन्स करता येते. फर्स्ट यू हॅव टू फाइंड आउट द angle theta, that from the Bragg's equations we can find out the values of this d proportional to 1 upon sine theta, and once we get the values and it's similar to the standard values like your FCC, BCC and simple cubic. So the KCl shows the simple similar values, that is the standard values like simple cubic structure, but it is from that equations and that values we can say that the KCl is a simple cubic lattice, but it belongs to the FCC crystal lattice, just like you are similar to the NaCl crystal. And when you pointed out the and calculate the ratio of this any one of the plane like 100 plane of is NaCl and KCl, and taking the ratio of this one, it will comes the value 1.113, and this is the values, and it takes their molecular ratio or the molecular volume or the volume of whole unit cell, and that will be the value is 1.379, and this is the values. It is exactly similar or a good agreement with the molecular ratio values of the experimentally calculated, and that value is 1.39. So this is the values which will be, it is the good agreement, and therefore we can say that it is the NaCl and KCl having the FCC or the face centered cubic structure. This is the reason. Second reason is that the reason for the showing scattering pattern of KCl as simple cubic cube, in KCl both K plus and the Cl minus ions, it's having a same 18 electron numbers in the outermost shell, but these scattering patterns, it is with the same extent, but and it is indistinguishable. But the scattering pattern in a NaCl crystals, because the NaCl crystal it is different, because the Na ions having the 10 electron system and the Cl minus ions having the 18 electron system, and therefore the scattering pattern is different. So this is all about the determination of crystal structure. Next and last point is in your syllabus or in your this topic, that is solid state chemistry. That is the characteristics of NaCl or KCl structures, or the similarities between the NaCl and KCl. NaCl आणि KCl मधली सिमिलॅरिटीज काय, हा लास्ट पॉइंट तुमचा आहे. त्याच्यानंतर आपण न्यूमेरिकल प्रॉब्लेम्स बघूया, पण ते नेक्स्ट लेक्चर्सला. लाईक